Okay guys, here we are with the final question of all of the paper 6s from the summer 21. This is question 5163 and it's another one of those planning questions. Alright, so hopefully we can draw on some of the experience from the previous videos. I really would encourage you to try these ones. I'll put a link to another one of these videos because I think they're quite particular, okay, these kind of questions, into how we structure our answers. And again, if you've done a couple of these, you'll feel a lot better for having had a bit of practice. So we want to know if the time taken for a metal ball rolling along a horizontal bench to come to a rest depends on its mass. So we're going to change the mass and measure the time. Okay, you got a plan experiment and you're given some apparatus, good, okay, and you're shown kind of how it's set up, and then you're told what to include. I'm not reading the question because I think everyone can do that themselves, but I'm going to highlight the things you need to do. Apparatus, and again, notice in our mark scheme we've got something about apparatus. A description of the method, MT, measurements, and then variables, V, and then conclusion, C. And you are, as usual, kind of the marks will come from each of these categories, usually 1 from each one, okay, and a maximum of 2 from each one. So you do not need to have all of this stuff, okay? This would be overkill. You see my answer is definitely overkill, all right, but we're trying to hit as many points as we can, but you don't have to, okay? All right, you can include a table of results. You're not required to do any data taking, so you don't need to write any values down. Okay, what do we do then? All right, we're going to set up the equipment shown in figure 5.1, and we're going to make sure that the angle, that's our angle there, theta, is constant. Let's have a look and see if I've got anything about that. Okay, key variable, that's a V. The angle of the ramp or the height of the ramp has to be the same. So this is going to be a control variable. It must be the same. Now there's other things, the release position, okay, and the size of the ball. Okay, so if I've mentioned that anywhere, I might get another mark for those, but I've mentioned that the angle of the ramp should be constant. That's a good start. You might also want to talk about how we measure that. Well, yep, I've said that there. Okay, I've just rotated my answer by mistake. Okay, we're going to measure it with a protractor. All right, that would be an additional little bit of detail. We're going to measure the mass of the metal ball, and we're going to use scales or a balance. There you go. There's our additional apparatus, scales. That's one mark there already. Okay, we're going to place the ball at the position of height C. We're going to measure height H. Sorry. We're going to measure H with a meter rule. Okay, and we're going to mark the starting point on the plank. There's no mark for that, but I think it would be just a sensible thing to do. Okay, we're then going to place the ball on the ramp and release it. Okay, simple bit of the experiment that you might forget to write about. We're going to let the ball run down the plank. And when it reaches the bottom, we're going to start a stop clock. Okay, that's an additional piece of kit. When it stops, we're going to stop the stop clock. And this is the stopping time T. We're going to repeat this for the same ball and calculate the average, okay? You notice we're going to repeat, okay? There's a lot of marks there. Start the timer, stop the timer, okay, and repeat. So it's 3 marks all in those couple of sentences. We're going to change the ball for one of the same size but different mass, and we're going to measure T, and we're going to do this for 5 more mass values. We're going to plot a graph of T on the y-axis and M on the x-axis and look for patterns. Okay, so you notice that I think I've got pretty much all the points here. All right, you notice how quickly we can kind of get those points down there. There's a very high value answer here. I'm not saying to you that you're expected to write anything of this level, but there are some basic marks in there. Look at those method marks for placing the ball on the ramp and releasing it, for starting the timer, for making a measurement of the mass, for measuring the time, for averaging, evened out, average, for plotting a graph, okay? So this is really basic approaches to scientific experiment planning, okay? I do think that it's more than within ourselves to get these marks, but I do think that students get put off maybe just by that big empty space in front of them. You can absolutely do this. I'll see if I can find any other examples of these kind of questions, but if I don't, I'll certainly include a link to another one in the bio for this one, just so you can have a look. Thanks for watching, folks. Any questions, please ask.